So today we're going to cover section 2 of chapter 8. Today we're going to learn how to prove triangles are similar using angle-angle. Now, this shortcut of angle-angle or AA only applies to triangles. Now, once we're finished and we learn section 8.3, we will learn 2 more shortcuts, and that's going to be side, 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 and side, angle, side. If you remember back to the congruent triangles, there were 5 shortcuts. But to prove triangles similar, there's only 3. And today we're going to learn the first one. So this is the angle-angle or the AA similarity theorem. And it states that if 2 angles of one triangle are congruent to 2 angles of a second triangle, then the 2 triangles are similar. And remember, similar means one is small, one is large. So it's going to have exactly the same shape, but different sizes. And this shortcut, again, only is for triangles. You cannot use it for a quadrilateral. Now, when we covered section 8.1, in order to find or prove that 2 polygons were similar, we had to show that every single angle had a congruent match and all the sides were proportional. Now, if I'm asking to prove 2 triangles are similar, all I need to look for are 2 congruent angle pairs. So in this particular picture, I've been given that angle A is congruent to angle D, because it's got the little congruency mark, and then I can also see that B is congruent to E. So because I have 2 congruent angle pairs, I can say that these 2 triangles are similar, and I can write a similarity statement. And that's what's pictured here. Triangle ABC is similar to triangle DEF. So when it asks you to write a similarity statement, this is what I'm asking for. So make sure you understand this terminology. So when you take the quiz next week. Notice all we were looking for were 2 pieces of information. Remember when we did the triangle congruence, we had to find 3 things, but this one only needs 2. But technically, angle C is actually congruent to angle F, because a long time ago, we learned the third angles theorem that stated if 2 angles of a triangle are congruent to each other, then the third pair would also be congruent. Now, they want us to tell whether the triangles pictured here are similar or not. Now, sometimes the triangles are going to be inside each other. So if it helps you to pull them apart so you can see it a little bit better, then do that. Sometimes, unlike the example before, or when we saw the official theorem, not always are the angles going to be marked. And this is where we're going to have to go back and use prior knowledge. And we're going to need that. For example 1A here, we're going to have to go back to chapter 3. And we're going to have to remember how to find corresponding angles which are congruent. So notice in the picture, all they're giving us is that these 2 sides here are parallel. Remember, the arrow indicates parallel. This isn't a congruency mark. Now I'm going to add some variables to this so I can actually practice writing a similarity statement. So I'm going to add the variable A up here, then B down here, C, and then D and E. Now the 2 triangles that it's asking me to prove are similar are going to be this one, little one that's up here on the top, compared to the whole big one, the ABC. So let me go ahead and redraw them. So this is triangle ABC, and then I have the little one up at the top, the ADE. Now, because I have parallel lines here, I know I can use the fact that this is parallel to this, And then I can say that this side over here is a transversal, making this angle here, this bottom angle of the little one, congruent to angle B down here, because these are corresponding angles and corresponding angles are congruent. So angle B is congruent to angle D. Now, the easiest other angle to find, I could do the other side as a transversal, but if you recognize that this angle A up at the top is the same in both triangles, and when you write a proof, you'll be writing a proof for this, that angle A is congruent to angle A, and that reason would be reflexive. So I've just now shown that I do have two congruent angle pairs. So I would say, yes, these triangles are similar using angle, angle, and my similarity statement could be that triangle ABC is similar to triangle ADE. Now I could have also gone back and shown that this angle E here is the same as angle C, because again, I could have used this as a transversal. Now, when you write this similarity statement, the congruent or the order of the letters matters. So notice the first letter I wrote was A, and it's congruent to A. And then B had the same marking as D, and then C was congruent to E. So the order that you write the similarity statement is important. It doesn't matter what you start with. I like to sometimes start with my first triangle I write down in alphabetical order, but technically there is no right or wrong order as long as everything matches. Let's try the next one. Again, I'm going to add some variables. This one's easy because everything's given to you. So here I'll put A, C, B, and then over here, let me just call this one XYZ. So notice angle B is marked as congruent to angle Y, and angle C congruent to Z. I don't even need to go back and get any prior knowledge. Everything was given to me. So again, these are congruent, again using angle, angle, and my similarity statement could be that triangle ABC is similar to triangle XYZ. And again, the order matters. Angle A needs to be congruent to X, B to Y, and then C to Z. So again, if it helps to pull it apart, you can redraw them. A lot of times when we start with the side angle side, it'll help to pull it apart, especially when there's a side that is shared. So the similarity is ABD, similar to triangle CBD. Let's try example D. Let's go on. So this one might be beneficial to pull apart. Let me add in the variables. So I have A, B, C, D, and E here. So this is B, this is E. So I'm referring to this one right here, the ABE. I'm going to redraw it, pull it apart so it's easier to see because they're not facing the same way. So only thing I have right now is a congruency mark on E. And then this one over here, the ACD, this is the larger one. And we can see that angle C is congruent to angle E. Now, if you notice, whenever they're on top of each other like this, generally there's an angle that's shared. And you can see that they both have angle A in common. So if you were writing a proof, you could say that angle A is congruent to angle A by reflexive. And now I have two angle pairs that are marked as congruent. So yes, these are similar, again, by using angle, angle. And my similarity statement could be that triangle ABE, the pink one, is similar to triangle ADC. So in the homework tonight, since you only know one shortcut, it's probably going to either be similar or it'll be AA. But tomorrow we learn the other two, and that's what'll get more challenging because you may not know which one you would be using. But tonight we only know one. So here it wants me to find the value of x. So let me go ahead and add the variables just so I can pull it apart, so it might be easier to see. So I have ABC here up at the top, and then I have the whole big triangle, the ADE. Now notice this time I only have parallel marks here, and I do have side lengths. So I'm going to realize that my sides in my similar figures are going to be proportional. So, but first let's prove that these are similar so I could show that the sides are proportional. So because I have the parallel lines, again, I could show that this angle is corresponding to this one, so they're congruent. And I could also do it on this side as well. This angle congruent here. Because again, these would be your parallels. And the first time I could use AD as a transversal. And then the second time use AE as the transversal. Technically, angle A is the same in both. So I could also do reflexive on that. All right, so now let me pull them apart so you can see the corresponding matches. So let me redraw the little one, the ABC, right there. And then draw the larger one, the ADE. So now that I've established that they are similar, the small one has a length AB here is 3 and AC is 5. However, to find the length of AD, I need to add 3 plus 1, and AD is 4. AE over here, notice it's got a 5 and an X, so its length is X plus 5. Now, I know they're proportional or I know they're similar because I found the congruent angles. And I can say they're similar by angle. So now I'm going to look for the corresponding sides. So I can see that AB is the corresponding side match with AD. And I'm going to put those together in a fraction. Technically, it doesn't matter if I do 3 over 4 or 4 over 3. I'm not asking to find a scale factor here. I'm just going to use it in my proportion. And then for the second fraction, I'm going to match the 5 with the x plus 5. Notice the numerator are both of the numbers from the small pink triangle, and the denominators came from the large blue triangle. Now I'm going to cross multiply and solve the equation. So I'm going to multiply diagonally, 4 times 5, and then 3 needs to get distributed to both the x and the 5. So I'm going to do 3 times the x plus 5, and then the 4 times the 5. So I need to distribute the 3 to the x and to the 5, multiply the 4 and the 5, and now solve my equation. Subtract 15. 3x equals 5. Divide by 3. And x equals 5/3. We can make it a mixed number. 3 goes into 5 once with 2 left over. I wouldn't make it a decimal because it actually turns into 1.6 repeating. So when it's a repeating decimal, just make it a mixed number. Okay, so for example 3, remember this right here is a similarity statement. So they want us to complete it. This is just finding the value of y. This is just finding the value of x. And what they want us to do here is complete this statement of proportionality. So you're going to have to do this on the quiz. So let's go ahead and take a look at what we have. And again, it may be beneficial to pull it apart. Again, I've got the parallel lines. So this should be a clue that we're going to be bringing back those alternate interior, the corresponding angles, all the stuff from chapter 3 again. All right, so the two triangles that I'm focusing on is this one right here compared to the whole thing, the ABC. So let me pull them apart. So again, I got the large one. And then the little red one. So D, E, B. And then this side had 3, 4, and a Y. Then the blue one, this is 8. Now to find the length of CB here, I have to add 3 plus 4, and CB here is 7. Over here, AB, notice it's got an X and a 3, so it's going to become X plus 3. Now, I need to find my congruent angles. So if you notice, they both have B in common. So B is congruent to itself by reflexive. And then I could also recognize that I've got the parallel lines here. And then I could use this as a transversal, which would make angle C here congruent to this angle BDE. And when it's pulled apart, it's just angle D. So I do have my congruent angles. This is going to help me figure out my similarity statement. So if you notice, angle A didn't have a mark, so it's going to match with the other angle that I didn't mark. But it is actually congruent to it if I use that other transversal. So ABC is similar to angle E because it matches with A. Then B is the same. And then D and C have the same match. So the similarity statement is that triangle ABC is similar to triangle EBD. Let's go ahead and fill in the statement of proportionality first. Then we'll go back and find the values of X and Y. Now they've already started the statement for me. So they're actually doing the red triangle in the numerator, all of those side lengths, and then the blue in the denominator. So it's BE over BA. So they've already shown me that this side is proportional to this one. So then if you notice, this side over here goes from the double congruency mark to the single. So it's going to match with the CB. So again, I'm doing the red triangle on top. So I'm going to be doing DB over CB. And then the last side that I can mark here is going to be this one here. The DE is going to match with the AC. I could have also referred back to my similarity statement to find the matches as well. So this will be DE is going to be proportional to the CA. That's your statement of proportionality. Now what we're going to do to find the values of X and Y, I'm going to use the two sides that have numbers. So if you notice this red here, the 4 and the 7, these are the two corresponding sides that have the numbers that could give me what I need to put in my proportion. So I'm going to use 4 over 7, and then I'm going to find out where X is located. And my X is located over here, the AB, and remember its corresponding proportional match is this EB. So I'm going to set this up as 4 over 7 is equal to 3 over X plus 3. Because remember, the numerators came from the red, and the denominators are coming from the blue. So now I'm going to cross multiply. 4 times the X plus 3 is equal to 3 times 7. Distribute, multiply, and now begin solving. Subtract the 12. 4x equals 9. Divide by 4. And x equals 9 over 4. When I make it a mixed number, 2 1/4 or 2.25. For y, you can see the y and the 8 are going to match. I'm still using the 4 over 7. But now I'm going to use the y and the 8. And again, remember, the numerator is coming from the red and the denominators are coming from the blue. Cross multiply, divide. 7 goes into 32 4 times with 4 left over. I would just leave this a mixed number because it is a repeating decimal. So x, you can either, I would put it as 2 1/4, and then here 4 4/7. Okay, so we're going to write a proof here. So statements and reasons. Go ahead and fill in your given. All we're given is that AC is parallel to BD. That's the only given we have. And we're trying to prove that triangle AOC is similar to triangle BOD. Now I can go ahead and, so we can go about solving this proof 2 different ways. So because we have the parallel lines here, and then I could use this as a transversal, this is now creating a pair of alternate interior angles. So this angle C here is congruent to angle D because these are alternate interior angles. So that could be my next statement, that angle C is congruent to angle D because of the alternate interior angles theorem. Now, technically what I can do, which might be the easiest, is also show that this could be a transversal going this way, and then I have a second pair of alternate interior angles. So in the exact same step, I could also say angle A congruent to angle B, and then I'm done because I've just shown 2 congruent angle pairs. So my next statement was what I'm trying to prove, that angle AOC is similar, or triangle AOC is similar to triangle BOD using angle. If you wanted to go about identifying the vertical angles here in the middle, you could have put that in as a angle pair instead of both alternate interior pairs. So instead of one of these, you could have taken one of these out, and instead you could have put that angle AOC is congruent to angle BOD because of your vertical angles congruence theorem. But honestly, it's probably a lot easier if you just use the 2 alternate interior angles pair, and you could solve this proof in 3 steps instead of 4. Okay, so this last example tends to show up a lot on SATs. This is your classic shadow question, and a lot of times a picture is not provided. So sometimes it may be beneficial if you give yourself a little sketch. And what we're using here to solve this is similar triangles. And we would match. We're going to match heights with heights and shadows with shadows. So if I draw my flagpole here, and then we've got its shadow, and then I have a woman who is standing nearby. And she also has a shadow. So the flagpole shadow is 50. the woman's shadow is 40. They also gave me the height of the woman. She's 5 feet 4 inches tall. And they want me to find the height of the flagpole. So I'm going to match the shadows. And again, because it's not asking for a scale factor or anything, it really doesn't matter the order that you put the numbers into the ratio or into the fraction. So I'm going to do 40 over 50. These are the two shadow lengths. And then simplify that fraction. It'll simplify 4 to 5. Now, before I can go ahead and work with the woman's height, I need to convert her height into inches. So I know that there are 12 inches in a foot. So I'm going to multiply 5 times 12 and then add the extra 4 inches. So her height in inches is 64. So notice when I did the shadows, this was the woman, this is the flag. So when I put the heights in my ratio or in my fraction, the numerator is going to be the woman's height, and then I don't know the flagpole. And now I'm going to cross multiply and divide. So I'm going to multiply 4 times x, and then 5 times 64. 5 times 64 is 320. And now I have to divide 320 by 4. And x is 80. Now these are inches. If you go back and read the question, they wanted the height of the flagpole rounded to the nearest foot. So I need to convert these inches back into feet. So again, 12 inches in a foot. So divide 80 by 12. It'll go in here 6 times. Subtract. And notice what's going to happen is it's going to start repeating. So it's 6.6 repeating, but it said round to the nearest foot, so that would be 7 feet. So approximately 7 feet tall is the flagpole.